Hello and Assalamualaikum. My name is Zulqarnain bin Hamidun. I am a Part 3 Mechanical Engineering student, and today I'm going to present about hydraulic braking system in an automobile. So the system consists of a brake pedal, a master cylinder, brake lines, caliper, disc, drum, and brake shoes. So in this presentation, I will explain how hydraulic braking system works, what the system is comprised of, and the mechanics of hydraulic braking system. So how does the hydraulic brake system in an automobile work? So basically, it transmits brake pedal force to wheel brakes through pressurized fluid, converting the fluid pressure into useful work of braking at the wheels. So this uses the Pascal principle, where Pascal principle states that in an enclosed container, a fluid at rest, when pressure is applied, it will transmit throughout the system uniformly. So in a hydraulic braking system, the braking force is directly proportional to the ratio of the master cylinder cross-sectional area to the disc or drum brake wheel cylinder cross-sectional areas. These cylinder diameters are appropriately chosen to produce the desired braking effect. So point number 2 and 3 I will explain later, since there's an equation to derive how they make the size of the area of pistons, the force exerted, and so on. So what is the system comprised of? Firstly, the brake pedal. The brake pedal receives force and transmits it to the master cylinder. Next is the brake master cylinder, the brake pipes, which transmits fluid throughout the system, the wheel cylinders or the caliper pistons. Wheel cylinders is usually for the rear tires, and the caliper pistons is usually for the front tires or for all four tires, depending on the model and type of car. So additional is the brake booster. So for the brake master cylinder is used to receive the force exerted on the pedal, and is used to convert the force to pressurized fluid. So when the pedal is pushed, the push rod is pushed forward, the circuit 2 rear seal will go over the fluid intake and return port. This causes pressure buildup in circuit 2. The buildup in circuit 2 causes the circuit 1 rear seal to move over to fluid intake and return port here, causes the pressure buildup in circuit 1. The pressurized fluid in both circuits is then transmitted along the brake lines to the wheel cylinders and caliper pistons. So wheel cylinders and caliper pistons, as the hydraulic line pressure acts on the cross-sectional area of the disc and drum cylinder piston in the wheel cylinders, the hydraulic pressure is converted into braking effort. This braking effort either presses the friction pads against the side face of the disc or forces the shoe friction linings against the inside of the drum. So this is the wheel cylinder and caliper. When the pressurized fluid enters the wheel cylinder, the pressurized fluid will push the pistons at both ends of the wheel cylinder outside, where the shoes are attached, and they will engage the drum brakes. This will cause deceleration. For the caliper, the piston is inside the caliper here. The O-ring and the dust seal is used to avoid leakage, since when the pressurized fluid enters, it pushes the piston outside towards the brake pads. So the brake pads will then engage the cylinder wheels and causes friction, which leads to deceleration. So the brake booster is an additional component. The brake booster comes in two types, where there are vacuum brake boosters, which usually uses the vacuum generated by engine and the diaphragm, while the second one is hydro boost. Hydro boost uses the pressure from the power steering pump. So the functionality is the same. It's to reduce amount of pressure when braking. increases force of pedal for lower mechanical pedal ratio. This is to ensure lower pedal travel. Lower mechanical pedal ratio causes shorter pedal travel. Normally 3.2 to 1 to 4 to 1 mechanical pedal ratio. So for the vacuum brake booster, the amount of force is dependent on the booster's diaphragm and the amount of vacuum generated by engine. As for the hydro boost, the amount of force is dependent on the pressure from the power steering pump. So this is the brake booster and hydro boost. This is an additional component in the braking systems to reduce the force needed when braking. So this is the equation how the mechanics of hydraulic braking system. So they have the cross-sectional area of master cylinder AM, cross-sectional area of front piston AF, cross-sectional area of rear piston AR, distance moved by effort LM, distance moved by output LW, pedal leverage ratio B/A. So this is the equation used to calculate the area of front piston, the rear piston, dependent on the you can find pressure and force here to get the desired size and the optimum braking effect. That is all. Thank you.